Hey kiddos, hope you're doing well. I'd like to, in this brief video, introduce you to the look, the shape, the graph of the sine and cosine function. So we're looking at what does y equals sine of x look like, and what does y equal cosine of x look like. And we're going to blast off from here tomorrow. So make sure you get this. So I found this nice little applet. It's a GeogebraTube.org, not my work. So it is nice because it illustrates how we move from the unit circle values of sine and cosine to the graph of the sine or cosine function. So we're first going to start with a sine function, right? Now recall that as if I rotate theta or x, then the y value of the terminal point or the height of the reference triangle, same thing, is defined to be within the unit circle with radius 1 is defined to be the sine of the angle that got me there, right? So we've been thinking a lot about how to get sine and cosine values for different angles. So let's look at what it would look like if we were to graph and plot all the angles x. So these are the angles along the x-axis, and all the sine of those angles y along the y-axis, right? So what I'm going to do is I'm going to begin by rotating, and I'm going to do it slowly, and you can see how each particular point is plotted on this plane, right? Oh, there's 90 degrees right about there, right? And then I'm going to keep moving, keep opening up that angle, and there's about pi radians, right? We remember the sine of pi is 0. And I'm going to keep working. And you can notice what's happening to the shape of the sine function, right? I'll start over. So as theta opens up, right, this is just plotting the sine of theta for different x or theta values, right, different angles of rotation, right? And what it's doing is it will continue onward in this pattern forever and ever because of the circular or cyclical or periodic nature of this function, right? And we'll talk about that tomorrow more specifically, right? So here is one period of the sine function, right? There's one shape, after which it will begin to repeat itself, right? And we can find the graph of this function on our calculator. So let's take a look at what that would look like. I'll show you how to do it. So please first make sure you're in radian mode. So hit the mode button, right? And make sure you're in radian mode, right? Press enter. And then we're going to make sure you have y equals sine of x. And then what we can do is we can zoom trig. And what that does is it gives me an x window. This is negative 2 pi, and this is positive 2 pi. Okay? So the window for the trig goes from negative 2 pi, that's about 2 pi, to positive 2 pi along the x-axis. It automatically fits it for us. Okay? And you can see that there, in this case, I have two periods or two cycles of the sine function, right? There's 1, and there's 2. 1, 2. Right? And we'll go on forever and ever like this, right? So let's think about domain and range, right? The domain for the sine function is all real numbers, right? There isn't an angle I cannot evaluate the sine value, right? You can go positive, you can go negative, we can go in any direction we want, okay? So the domain for the sine and cosine functions are all reals. The range, however, because we're bounded within the one unit circle, the range for this function will travel no further than positive 1, right? That's the highest value we can get. And it will travel no further below negative 1, right? So the range are all the y values between and including 1 and negative 1, right? So you can see that here, right? Here's y equals 1, and then down here is y equals negative 1, right? 1, negative 1. So the sine and cosine too, as functions, are kind of caught between as far as their outputs or their range, negative 1 and 1, including 1 and negative 1. Okay. Note that the sine function travels through the origin, 0, 0. Okay. That's how a lot of people remember. The sine function travels through the point 0, 0, since the sine of 0 is 0, right? Since the sine of 0, if I rotate 0, the y value of my terminal point is 0, and it'll go anywhere. That should be the point positive 1, 0. But either way, it's the y value of my terminal point. So therefore, the sine function, because the sine of 0 equals 0, goes through the origin, the point 0, 0. Right? So there's our origin right there. Bam. Okay. So that's a sine function. Let's take a look at the cosine function, right? And let's rewind. Actually, let's go back to sine, and let's bring that whole guy back, or at least part of it. Now let's go to cosine, okay? And so the cosine function, I'll graph it up here too. I'm going to change that to cosine. Cosine and sine are their own buttons. They're that important. Big deals. I'm going to graph that. And cosine looks a little bit different, but not too different. So here's the cosine function. And the cosine starts at, quote unquote, starts at 1, meaning that the cosine of 0 is positive 1, not negative 1, but positive 1. So therefore, cosine should go through the point 0, 1, right? So we start up at 0, 1, and again, remember the cosine, by definition, is the x value of my terminal point. I don't know why that's negative. Or the base of the reference triangle, whatever works. And so note that as we're opening up theta, or x, the degree, the independent variable, those values are being plopped right onto this graph, right? And we're getting the graph of the cosine function. Here are angles along the x-axis, and here are the sine of those angles along the y-axis, right? And it will continue along this way too, right? So the cosine of 0 is 1, right? So therefore it's going to go through the point 0, 1. And then as I open up the angle, it's going to drop. Cosine of pi over 2 is 0, right? Pi over 2. And then it's going to continue moving downward. Cosine of 3 pi over 2 is 0. 5 pi over 2 is 0, etc., etc., right? So there's a cycle and a half, approximately, of the cosine function. Here are 2 cycles, or 2 periods, of the cosine function from negative 2 pi to pi. And here's 0, 1, and again it's moving just like the cosine. As far as the range is concerned, the cosine, like the sine, the range is between 1 and negative 1 inclusive, right? Just like the sine, the cosine has a domain of all real numbers. There, we can take the sine or cosine of any angle. Okay. So very similar. Let me graph both of them at the same time, and you can see how kind of we can plot them together, right? So there are the cosine and sine values being plotted. And they look pretty similar, wouldn't you say? In fact, they are very similar. Each is a translation of the other. Okay. So one thing I want you to just get comfortable with the graphs of the sines and cosines, right? The cosine, quote unquote, starts up here at 0, 1. The sine goes through the origin, 0, 0. But of course, these continue in both directions infinitely as x gets negative or more negative. Okay. The second thing I want you to do for homework is as follows, okay? And I'll write it in the Canvas assignment, but I want you to be comfortable with sine and cosine functions, or at least part of them for now. And I have some questions I'm going to ask you to research, okay? So check Canvas for the second piece. Bye-bye.